Hi everybody. As he said, my name's Jasmine. I'm going to be talking to you today about these wonderful tools, Prometheus and Grafana, and using them together effectively, especially to make service dashboards. So I've been using these technologies for a while now. I'm with WebPT, and I've been helping them set some stuff up with a Kubernetes infrastructure. And these tools have been amazing, and I've learned a lot of things along the way, and so I'm here to share some of those things with you today. So first off, can I get a check? Can we raise hands if anybody here has actually used Prometheus before? If you've ever, awesome. If you've ever written a query. All right, what about Grafana? Has anyone ever written a dashboard? How about made dashboard variables? All right, a couple people, awesome. So if you're not familiar, for those who didn't raise their hand or read anything, where all of this fits in is you generally have something that you care about, probably something that does work. It could be an application, could be a web server, could be a database, could be a file that's being accessed, could be a thing on the Internet of Things, really anything. The idea is that they are accessed, or they have some kind of thing in how you operate with them. And so where Prometheus fits in is this notion of instrumentation. And so you can either do it in your code using a Prometheus client library, which there are for many languages, probably the easiest way to get going if you have your own custom things. And then you can also do it from outside of your app using external exporters, as they're called, which might probe your app, diagnostics, do any kind of thing, and then send that back. And then lastly, you might do something kind of more coarse-grained and just kind of like check a service if it's up or not, and just kind of probe its statistics if it's around. And so these libraries, daemons, and the probe, they basically go and check your thing, see how many times it's been accessed, how fast it's responding, whatever. Then they hold on to that. And so then you run Prometheus itself. And he goes and talks to all of those. They're what are called scrape targets. And whatever things that they've picked up on, they then share with Prometheus, and he gathers them all together. And so the point of all of this is that we can then go to Prometheus and ask questions about these time series. Things like if we've been counting accesses, how high have they gotten? How fast are they counting up over time? And when are they there? And if we haven't seen them, or if they're different things, like say you have multiple web servers in a server pool, when have they come and when have they gone? So another thing that Prometheus allows us to do is with our, say we're tracking accesses, you can do the notion of labeling. And so now for every access that you track, you're actually tracking some additional dimensions. And these can be anything that you want. The example here is just tracking who and what they're doing. Obviously a fake example, the who would probably be IPs or a logged in user ID or maybe a user class, depending on what you're trying to do. The labels could also be, was the access successful, or were they denied? Was it an authentication problem or something like that, status code? And what's nice about Prometheus is that with these labels, we can totally disregard them and just go back to the original counter that we had. So how many accesses did we have in total? And then you can also slice and dice. So if you only wanted to see certain things, like out of all of those things, I don't care about the pages, I just care about the who, or maybe vice versa. So Prometheus is all about giving you great abilities to query through this type of stuff. And probably more important, when you have these sub-items and the full set, you're able to actually calculate ratios. So we could see, this is a kind of a crappy example, but what is our about page rate? You know, out of all the accesses, how many of them were on the about page? This is a crappier example, but a more real one would be if you had errors. What's your error rate? How many errors over all of your accesses? And that's a pretty useful statistic. So Prometheus itself really, aside from a basic HTTP UI for just kind of checking your metrics, offers an API. And so with that, you can query it with your own purposes, throw that on a table, use a charting library, D3 or something, or forward it to another Prometheus instance if you're doing some kind of federation, if you have like a multiple clusters set up. Or maybe you just want to hold your metrics for a lot longer, but you have too many. So you can reduce your set in the second instance and have a longer retention time. So why just Prometheus? Why not just Prometheus? So when it comes to having all of those data, we eventually want to combine those queries and interact with them visually, kind of get more than just the UI, which isn't really that interactive. Ideally, we want to turn those accesses and counters into something more useful. And so when it comes to custom things, it could look something like this. The top one's a Sankey diagram, and the bottom one is actually just a little, there's a little syntax called mermaid.js, which allows you to just create nodes and connect them together with a nice little syntax. And these originally would have to be done manually using something like D3 or some other library, but actually both of these pictures are from Prometheus plugins, from Grafana plugins. And so speaking of Grafana, we can, as I mentioned, query the API and do stuff with it. But Grafana can already do that. That's kind of Grafana's whole job. And so even if you are going to do your own custom thing, Grafana is a great place to start. May even be able to help you get going as you're working on your custom thing. I know that these slides are supposed to be shared, so all throughout my presentation, there's tons of links. If you have the site, you should be able to just click them. Otherwise, you should be able to type them in. Those two particular threads, it's a GitHub issue, but there's a discussion in it about using things like D3. Some of the libraries that I showed pictures of are in there, as well as a way to just use the text chart in Grafana to throw your own stuff in without even having to make a custom charting plugin or anything. So Grafana itself, for those who aren't familiar with it, it likes to query things too, kind of like Prometheus with the scrape targets, but it's only doing it to serve your needs. So with Grafana, you essentially create dashboards which contain your queries against the data sources. And so it's only going to query things whenever you want to view that dashboard or when you want to pan the dashboard or filter it or do something to it. So where Grafana comes in handy, as I started to allude to, is you can bring in multiple charts together. So as Prometheus just lets you kind of explore one of your time series, Grafana actually lets you combine multiple time series on one chart, have multiple charts. Your charts can actually be coordinated so that when you hover over a certain time on one, the same time highlights on all of the others so that you can easily correlate. You know, if something rose up here and you had another chart with some dips, you can maybe see if they correlate or not. Grafana also adds in the ability of what they call variables, which are pretty amazing, and they help to make your queries far more dynamic in your dashboards. So now that we have the two basic players out of the way, some important things to note are not all metrics are created equal. So how high something is right now is not the same thing as how fast it's risen over time. And so Prometheus contains this as a notion of instant metrics versus range metrics. And Grafana also handles this, and I'll show a picture. I guess I'll just do that now. So in Prometheus, you do instant variables by using the console tab on the right, or it's just, I think, the graph endpoint if you're using the API directly. And then to see things over time, you use the graph console here, and it's actually, I think, graph_ranges in the API. And you can see the previous one was a number. It's actually at like 56,000. So it's maybe at 56,000 here, but over time it was lower, and it just kept going up. So Grafana, when you view this, if you were to initially render the same query that we were just looking at, you'd see that same line. I didn't bother putting the picture to not bore your time, but I wanted to highlight this instant checkbox, as that's the guy who I'm talking about here. So in this picture, I've checked the instant, and I'm hovering over just a random time. But if you notice, it's at 57,000, and there is no line. If I were to drag the mouse, all the time is 57.56,000 because it's showing the one instant. So it doesn't have a notion of time. So a line graph is not the best use for instant variables, but where it comes into play is, say, a table. So here we're looking at the exact same query, but now rendered in a Grafana table with instant and not checked. And if you notice, we have over 6 pages worth of data. And the data is actually not that helpful. It's set up of times and values, and you might be able to guess it's basically a table of that line that we saw going up. As time goes further, the number goes higher. Not really probably what you're looking for. So this is a case where instant is exactly what you want, because you just want what are we at right now, potentially. So that's an important distinction between metrics, because you're going to need to know that to be effective. One part of being effective is knowing what your goal is and what you're trying to do. And then another part is knowing what you're going to need available to help you accomplish that. So to be effective with Prometheus and Grafana in tandem, let's focus a little bit more on Prometheus itself again. So Prometheus is recording what we referred to as accesses before, and they're just recording what we referred to as accesses before, and they're just numbers. In particular, they're 64-bit floating point numbers, so there's nothing super special. They're super high granularity, but that's pretty much it. So it's just numbers. But we can use that for more than just counting. If we were to, before we handle that access, take the current system time, do the access, take the system time again, diff the two, then we have a duration, and that can still be represented as a number. There's some complexity I'm leaving out there, such as our exporter, our client code. If we reboot, then our counter, which thought that we've been accessed 60 times, it's probably going to reset back to 0, and then when somebody hits us, now we've been accessed 1 time. So that's not great, but Prometheus thankfully handles things like counter resets like that for us, but that doesn't mean you don't have to know what you're doing. So the first question that people usually come when they start messing with Prometheus is, how fast should I be scraping those targets that we talked about? And it goes back to what I just mentioned of, what are you trying to do? That's always going to be your #1 goal. But if you know what that is, there are some things that we can do to help make decisions based on that. And so the largest impact you're going to run into is this thing that some people have termed the Nyquist-Shannon sampling theorem, or the Nyquist rate for short. And all it really means is, if we look at this graph up here in the top right, you see how there's these little black dots. The idea is that when Prometheus is scraping every now and then, that's one of the black dots. And so if you're only scraping every so often, let's say 60 seconds, then you might begin to think that, okay, when I hit it the first time, it's really high. When I hit it the second time, it's kind of low. Third time again, kind of low. And then it goes back up. And so you might think that you're actually looking at something that, if you were to continuously graph it, is that dashed line. But in reality, it could be that red line moving twice as fast. But you're experiencing aliasing because you just can't see what's actually happening. And so there is no real perfect rate of how often you want to scrape. It really does depend on your use case. If you want to be able to see what that red line is really doing, you're going to have to scrape at the speed of that red line. Anything slower, and you will risk some chance of aliasing. Other than that, the largest thing to know about Prometheus when you get started with it is it's also not intended to be a primary database. When it comes to metrics, its whole job is to gather this data and calculate it, but if some of it gets lost along the way, no big deal. It's not trying to slow down anything. In particular, for example, the Java client, a counter can increment, I think, in like less than 17 nanoseconds. So they're very specifically trying to make it low impact. It's not like logging or anything. There's no stream manipulation going on. But because it's lossy but approximate, you don't want to rely on, like, your actual data. You want to actually store that in a database that's designed to be ACID compliant and probably has master slave and all that kind of stuff. That being said, you can always use Prometheus to still get those numbers back out of that database. Or if you're using discrete logging, there's ways to, and I'll mention some tools later, to get your logs back into Prometheus. So when it comes to Prometheus, I mentioned there's numbers, and Prometheus splits those numbers into 4 kinds, and there's really 2 groups of these 4 kinds. So counters are the ones that we've basically talked about so far. They just go up. They might start at 0, so they might reset, but they're always going to go up. You don't hit the website and then it goes -1 views. Gauges, however, they can be set to anything arbitrarily. They can also go up. They can go down. The thing about these 2 is that they're recording the last seen value whenever Prometheus scrapes. So if you're getting hit and you're recording the last duration I saw, hey, it took 200 milliseconds, and then another one comes in, little network lag, that took 350 milliseconds, and then Prometheus scrapes, it thinks it took 350 milliseconds, even though the first one right before took 200, and maybe right after the scrape, the next one takes 150. So to get around that, they introduced the notion of histograms and summaries. And so what they do is, instead of just recording this last value that happened, they try to record a range of values. And so whenever they observe a value happening, they figure out where in that range that value fits, and then they increment a bucket counter for that value. So this way it can get around if within one scrape you've been hit 10 different times, we can at least observe all 10 values and see where they statistically fell. That way you're actually getting slightly more, you're not losing all of the granularity of your data. So the difference between a histogram and a summary is basically on how they aggregate it. In the histogram, you have pre-bucketed your data. So if we just keep going with the access times, then you might pre-bucket it as in 0 to 10 milliseconds, 10 to 50 milliseconds, 50 to 100, 100 to 200, whatever your SLAs are based around. And so then it can tell you, you had 30 requests that came in under 100 milliseconds. You had 15 that came in, under 150 milliseconds. So you're able to get some statistical useful data. Summaries, however, do the exact same thing, but instead of using hard buckets, they actually just accept all the values and then find where they mathematically fit in a linear scale of quantiles. And so it really, the difference comes into how you access from them. Do you have to know ahead of time your buckets, or ahead of time kind of your general ranges that you want to have stuff fall in? When it comes to all these different types, min and max are usually the safest things to use and are actually the most helpful generally. It doesn't really matter if your average is pretty speedy if your max is pretty low. So I include some links that you can check out on your own time if you're interested, specifically around histograms and summaries. They're very wonderful things, but if you do want to use them for business critical things, I definitely implore you to read these links, because for most things it's not going to matter, but if you try to base your service level agreements based on this, then I mentioned they're approximations. And so approximations are only as good as those buckets or those quantiles are configured to be. So what this could mean, and I don't have this on a slide, I apologize, but if you had an SLA of, say, 300 milliseconds, you might actually be at 240. And so you actually have like 60 milliseconds of headroom, but it might approximate that you're at like 275. And so now you might think that you only have 25. Or worse, depending on how your buckets are, it might estimate that you're over your SLA. And so that could be, you know, are we actually over my SLA? You got to be able to trust your tools, and you can only trust them if you've set them up properly. But that's also going to be based on your SLA. There's no one size fits all for everybody, unfortunately. So that's Prometheus. How can we be effective with Grafana itself before we talk about them together? So Grafana, as I mentioned, can handle multiple data sources. Prometheus is just one of them. Whenever it handles a data source, it actually adapts the query to that given data source. So for Prometheus, that means that it has that instant checkbox like we talked about, because that's a Prometheus concept. And then it also gives us a form of IntelliSense. So as you type, it shows you all the functions that Prometheus offers, including some blurbs about it, what the function does, its arguments. So it's just saving you from having to go to the documentation. But then it also will IntelliSense the metrics that you have in your Prometheus database. So if you've injected accesses and you start typing in access, it'll pop up with your metrics. So it kind of makes it easy to go through. And the talk's not on Elasticsearch, but just to give an example, Elasticsearch is based on Apache Lucene. It's a full text searching technology. And so when you use Elasticsearch, when Grafana can tell that you're using Elasticsearch as your data source, it uses a wholly different query mechanism that helps you build up Lucene queries. And Elasticsearch is really big on aggregations, so it does a lot of things to help you do those aggregations. The other thing that Grafana offers is visually intuitive alerting. So when you have a dashboard and you know, it kind of goes up to the top, and maybe you have like, you know, 100%, that's too much usage. By visually intuitive, you're able to literally just drag a little guy and drag it to 100 or wherever that line should be, and that's defining an alert for you. And so that's kind of handy because it's data source agnostic. Anyone can do it. If you go to that dashboard and you see a value that's bad or it should never go there, you can drag an alert to it and define something. And so that's kind of handy. But it also offers some drawbacks, because I didn't mention it yet, but Prometheus also handles alerting. In fact, Prometheus is designed from the ground up to handle it. It uses a separate binary called Alert Manager, but they're one and the same in the same family. And we'll revisit alerting later to see when you should use one or the other there. So I also mentioned that there's different technologies for grabbing your logs and turning them into metrics. I don't anticipate anybody reading that right now, but again, hopefully you can download the slides later, and if you're interested, you can check some of those out. The first one is an exporter that queries an Elasticsearch cluster for and any query that comes back. Elasticsearch calls it hits, how many things you found, and then you can aggregate, and it will turn those aggregations and hits into metrics. The remaining ones are for those of you who don't have an Elasticsearch cluster. They basically are a variety of things that will tail or do other things to grab logs or extract logs. The last one, Telegraph, can basically do all of it. It can pull from Elasticsearch as well. So moving on. You can also combine data sources. So in Grafana, you can make a dashboard, and you could have a graph that's pulling from Prometheus and a graph that's pulling from Elasticsearch, and they can live happily side by side. And as you pan through time, they both show the same time ranges. And you can also link dashboards. So if you're looking at a dashboard and it's kind of, you know, like, hey, that's great. One of the out of our overall response time, it's slow. What's making it slow? You can link your dashboard, so then you could just click that and then hopefully be taken to a better dashboard that then tells you which things are slow or why it's slow. So then lastly, and I think I touched on this already, Grafana provides dashboard variables, and they can really extend the depth of a dashboard, and they're a very critical part of this talk. So we're going to move on to them. So variables allow you to filter things down out of your metrics. So if we went back to the accesses demo that we were talking about before, you could have at the top of your dashboard a drop-down that shows Prometheus and Bob, or the about and home pages. And so then you could use that to filter down and only see those things or all of those things. You can also use variables to repeat a given chart multiple times, or to even repeat entire rows multiple times. And that can be useful for when sometimes you have a lot of services that to put them all on the same chart, it's a little bit noisy. You have lines kind of crossing each other and stacking on top of each other. And there's ways Grafana allows you around that, like stacking them literally. But that brings its own problems of now if one's going 0 to 10 and one's going 0 to 10, one's actually going from 10 to 20 to show it's 0 to 10. So that's kind of goofy. So being able to repeat can be handy, because then you just see the same chart side by side, but only each line in its own dedicated chart, or depending on how you want to set it up. So variables can also be hidden. So if you were to do that sort of thing, like say you were making a dashboard and you have, say you're doing Elasticsearch and it has all sorts of timings. It gives metrics for how long is it taking to flush logs, how long is it taking to merge indices, how long is it doing different things. You might not want to make 15 different dashboards for all of that, especially when they're all doing the same kind of thing, just how long did it take? So you might just do one, and then define a variable that selects all those different time series, and then just repeat your chart on that. So now you've made the chart once, and it'll just have one chart for each time series, and if you ever make a change, it'll update them all at the same time. And then you can hide that variable, so then the users don't even see it. You just have 15 charts there with less work on your part. So variables, I mentioned that they could be grabbing labels, but they can also be static values, and they can also be the result of very complex queries. They can reflect what's currently in the selected time range, or they could also select everything that's global. And that has a major impact on the user. And it kind of depends on your workload. But let's say that you are in a Kubernetes type environment where you have lots of pods that might come and they might go. If you have some filtering and it's showing all the pods that have ever existed, I'm not sure how familiar a lot of you are with Kubernetes, but it really helps you scale up and scale down things. So you might have 10, you might have 100, you could even have thousands. And going through a list there might be pretty tough if you click on a couple and then just the dashboards all go blank, because you selected a pod that was deleted 3 days ago, but you're seeing all the pods that have ever existed. And so it can kind of make it counterintuitive there. And then conversely, if you have something selected and you pan off, then the data goes away. You can also make it only show what's currently available. So then if you've selected some time range, it only shows the pods that were existing at that time. And that can be kind of handy. But now if you start panning, your selections might change, and that can be kind of goofy. So I don't know if there's really a perfect solution for that situation, other than seeing it as a hint that maybe your dashboard's trying to do too much. So in that case, what I would suggest doing is duplicating your dashboard. Just go into it and save as, save a new one. And you can keep the original one there for the let that be your fine grain one. But on the new copy, aggregate away whatever that noisy 1,000 pod, if that was it, then aggregate away the pods so that you don't care about the pods. And what that'll give you is a graph that's still showing you the same thing, but in aggregate. And so now when you pan, it doesn't matter how many pods came or went away, there's always going to be a line there. And so it'll always make sense. And especially for most people, which we'll get into the users in a moment, that's going to be what they care about. It's going to be a developer who's trying to figure out why something's wrong, who's going to care about the more detailed one. But he might actually need it, so you don't necessarily want to get rid of it. So just to sum up there, if you have a noisy dashboard, try to remove or aggregate away the highest cardinality. Cardinality is just how many things there are. Male and female is like a low cardinality dimension. The name of everybody here would be a high cardinality dimension because there's probably thousands, whereas there's only 2 genders or maybe 3 or 4 depending on your specifics. And then if they're less important, if you don't care about pods, if you just, most of the time you're caring, is my service working? You probably don't even care that your service is made up of pods. It's just, is it working? Can users hit it? Kind of like in the keynote, Netflix was caring about, can people stream? That's really the most important thing for them, right? So let's see here. Variables also enable compaction of your dashboards. So I don't have a good picture example right here, but in Grafana, when you map your thing, like let's say we were doing that accesses, then we would have one for Prometheus and one for Bob, or one for however many pages. You basically get a little legend that shows you what each line on the graph is and allows you to color them and do whatever. If you have multiple charts that are all rendering the same thing, that's a lot of redundant stuff. And so by using variables to select those things and allow them to filter down, you can just hide those labels, because when you select the variable, all the charts will now only show that variable. And so you can just hide your labels, or sorry, hide your legends, which can give you more compact dashboards. I think the microphone fell. Oh, no, that's the tape, sorry. Variables, I mentioned Grafana lets you link between dashboards. Variables help you make those links even richer. So you can maintain whatever variables you have on the page, including the time range. So if you've zoomed into a certain spot and you filter down to only see Prometheus, then now even when you go to other dashboards, it will keep looking at just Prometheus and only at that time range, which can really help the user experience. It does have a cost, because it means that your 2 dashboards, or however many dashboards, do need to share the same variable and kind of agree on that. But it's definitely more than worth it because of the user experience. It allows the dashboards to load way quicker, and it's just better all around. Lastly, queries can actually reference other variables, or sorry, variable queries can reference other variables. So continuing with the accesses example, we have Prometheus and we have different pages. You could say, if we had a drop-down that's just querying all the people that were ever in Who, so we had Bob and Prometheus, and then we had our pages, you can make the pages not just query all the pages, but all the pages that were matched by the selected Whos. And so then if we were to hit Prometheus, pages would just show Home and About, and if we were to just hit the other one, or someone who had only gone to only About, the About would reduce down. And so that can be pretty interesting for making, kind of with our previous example of where you had thousands of pods, that might be untenable. But for a developer who kind of knows what's going on in the cluster, if they could filter it down by namespace or by deployment or something, that might not actually be so bad, because now they can see all the pods in their namespace, or all the pods that belong to a given deployment, or other things like that. So it can be kind of useful. With Prometheus and Grafana's multi-select variables, well, with the Grafana's variables, they also have a functionality that can let you go into a multi-select mode. Oh crap, I'm running low on time. And the big thing to note there is instead of just doing an equals, you actually want to use the regular expression. Grafana will automatically handle passing them through delimited. So if you select 2 or 3 things, Prometheus will see those 3 things, but only if you've given it a regular expression. If you've given it equals, then it's going to look for a value that's literally those things all matched together. If you're using the latest version of Grafana, then you still have to use the regular expression in your queries, but you don't actually have to specify the select all. It's just built into it now. And there's also some newly introduced global variables that allow referencing the selected time range in your queries, which really enables some cool top-end graphing capabilities. And so I included some links there. So if you're using the newest versions of Grafana, you should definitely check that out. Another interesting thing with the Grafana's variables are called tag groups. And they allow associating, say you had all those pods and you have them in a namespace, you can associate those 2 facts together. So that way you could just click the namespace, here shown kind of backend and country. If they were to click backend, all of the backends would be selected. In this picture, they've deselected backend 1 and 4 after clicking that. It's not super smart, so it doesn't try to, like, if you select all the countries, it doesn't automatically select the country tag or anything. It's just a shorthand one way, but if you click country, it'll select them all. To use tag groups, the documentation's a little iffy on it. So I just provided this example here. You don't have to worry if it doesn't make too much sense. The big thing to note is the query here is grabbing instance. There's a label of instance, which might be the IP address of the server, the host name of the server, whatever's being scraped. And then we have this tags query, and we're grabbing the Kubernetes namespace, so the namespace that that time series is reported to have happened in. And then the magic happens in this tag values query, and we're now just grabbing, it's always the same time series, and we're filtering on Kubernetes namespace, and whatever these ones were selected will come through this tag variable, and then we just grab the instance from that. And that's how it matches up the instances belong to those instances. So how your metrics are set up in Prometheus can definitely affect how you're going to write your queries for your dashboards in Grafana. So for example, if you have things as different time series, then in Grafana's query editor, you're going to probably have multiple queries. And that will allow you to order them up and down, which is kind of handy and can let you control the legends. So it gives you a lot of control over the display. Alternatively, you could make that happen in just one query by using regular expressions again. And so I've mentioned Prometheus has labels. The time series name is actually also a label. Everything's a label when it comes to Prometheus. And so it's a special label called __name __. So if you were to do a regular expression on that, then you can do a regular expression on your time series names, basically. And so if you have the opposite situation and all of your time series or all of your different data is already on one time series with a lot of different labels, then the easiest thing is to just have that one query in Grafana and then use the legend to split them out based on their label. But then you might feel like you've lost your ordering because you can't just order things up and down and you can't customize them. Grafana has a notion of series thresholds, which allow you to identify a series by its name and then do things to it. And you can use that to reorder them. So even if it came through with, like, say, all of your CPU things, your still time, your idle time, whatever, then you could use that to make sure that, like, idle time goes to the top or the bottom. And also, conversely, if you have that situation where you have a lot of different time series that are only differentiated by labels, and you do want to have multiple queries, you can still make different queries, and then just duplicate the time series. Basically, duplicate your query and then filter it down. And so you'll just have the same query with a different filter on each query entry, but that allows you to recreate the original effect. It's really all about whatever's easiest for you to maintain. Having 6 queries means if you made a mistake or you need to now sum all of those, you have to do that all 6 times. If you have the one query, do it once and you're good. So series thresholds also have some other really cool capabilities. Normally, this would just be a chart that has 3 lines, one that goes up to here, one that goes up to here, one that goes up to there. That ends up by default being actually kind of noisy because they also have a fill color by default, so they start tinting each other underneath. All that I've done in this picture is taken the max, defined a series threshold for max, and said fill below to min. And so it's automatically taken away the fill from the max and the min lines, and then only highlights the portion there. It's just a good bit easier to read in my mind. Then I usually create another series threshold for the average to make sure it's on top and looks prettier. So yeah, hiding the fill color really helps improve the data to ink ratio, which is a graphing term for basically how much noise is there on the graph versus actual useful data. So combining time series, and we're almost done. So Prometheus allows some really powerful ways to group your metrics, even if they don't have labels or even if they're just completely different time series. So a couple of the techniques that we have available are when you're combining things, you can use the on operator and the ignoring operator to whitelist or blacklist labels. So you saw this in the previous example. I was like, hey, I want to see all of my accesses for a given person, and then I want to see over all of them. By default, it would match person to person, so you say ignoring people, and so then it, on the second one, it ignores that metric and just sees all of them. And I'll give some links that demonstrate all of these. Another option when you have multiple labels that might match on either side, Prometheus isn't magic, so you have to tell it, should you prefer the left or the right side when aggregating these metrics. We can also reduce label sets when aggregating using by and without operators. So if you were going to sum up everything, you could say sum it up by person, and then it'll give you a sum split out by every person label. And then if you have completely disjointed time series, or say you have an exporter that's not been configured and it's giving something in Kubernetes _ namespace, and you have something else that just says namespace, If you want to match them, then you can use label replace to convert the namespace to Kubernetes namespace or Kubernetes namespace to namespace. So then they match, and Prometheus can do some fun things to it. So for each of those things, there's some examples that go into an example metric, and most of the times they actually give several, and just goes into more nuances, good things to know about each. So I felt it was better to let Brian Brazil explain it than me. So if you're doing a lot of that, then do consider being a little more performant about it. That's kind of the last resort. If you have all of those things running and they're putting out those metrics like that, this shows you that you can make it work, but it's kind of inefficient because you're still, if you're doing that label replace, then now you're querying all of these things for each one, adding this thing, and then doing matching. Way better to just do it once. And recording rules can help you do that, and I provided tons of links here. Each one's got some slightly different tips that it shows, but doing this at ingestion time lets Prometheus just do it once, and then your label just has the right labels, so then your query time's faster, makes Prometheus happier as well. If possible, go higher than that and go to your exporter itself. It probably has a configuration file, and if it's your application's metrics, your developers can definitely manipulate the labels or time series that they're outputting. This is always going to be the preference because it's the least wasteful, right? No one's having to ingest and then throw away stuff or ingest and then rewrite stuff. It just comes in the right format. So when making dashboards, as I mentioned, smaller dashboards are actually better. They load faster and they're less confusing, at least assuming they're split out in a useful way so that you can get to what you need to do. So for linking charts, there's a couple of different ways. A chart has the notion of a drill down link, and it can, as I mentioned, share variables and keep the time series and everything. And when you actually go to a dashboard, you can make a panel go full screen. And if you pay attention to the URL, it adds these query parameters. And you can just basically repeat them in your URL parameters. And now when you follow that link, it'll take you to that dashboard with that chart as full screen. You can also, in your dashboard itself, create links based on search criteria or dashboard tags. And those will show up in the top right of your dashboard, and they will also keep variables and stuff for you. Those are super handy. So like if you had that Elasticsearch example, you might have a whole dashboard just dedicated to the timings, and then maybe one dedicated to like the cluster health or the disk space. And then you might have those linked. So that way, instead of one dashboard you have to scroll through, you just click on the one you care about, and everything's above the fold, loads quickly, and is nice and fast. And then you can also create a text chart. As I mentioned, you can use them for a lot of things, but they accept HTML or Markdown. You could add wiki links, Kibana links, other dashboard links. They also use variables, so any of the variables in your dashboard can be reflected there. And earlier I mentioned consider your users. The most important thing is knowing, to making effective dashboards, is knowing who your user is and what they're trying to do. Some people just want to know, is anything wrong? And that's it. They don't care which thing's wrong, just is anything wrong? Just give me something to look at. I want to see green or red lights. Other times, a person's been told something slow, and it's their job to figure out what's slow. And then at other times, someone has been told their thing is slowing down, and they want to know, has this been happening slowly over time, or did something happen recently that caused this? And each of those is going to be served potentially by a different dashboard. Also, as I mentioned, splitting dashboards, you can split them by tags, and if you're using the newer versions of Grafana, they've added folders. So you can also group them up by there. I've kind of already mentioned it, but a natural hierarchy I like to do is to have the most coarsest dashboard at the top that aggregates everything. So it always has like the one or just a few time series. And those drill down into finer ones which split out by the resource. And the thing I want to call out here is that when I do this, I actually do the same variables even on the top level dashboard. I don't usually intend for people to start filtering there. I intend for them to just see everything at a glance. And after they zoom in, that's when they'll likely filter or do the time range. But the idea is if they go back up to the top, I want to keep their filter and their time range. And in the top level, you might show some other things like maybe the max. So like, hey, here's the maximum CPU time or response time for a service to see how bad it can get. And so if you zoomed in and you're only looking at your one service, now you can zoom all the way back up, see your one service and how it compares to the max. In that case, you would have your max and your min lines actually not respecting the variable on purpose. You could also put the min and max on those lower detailed charts, but I tend to avoid it because that's just extra noise. If you already have a 10 time series on there, then having another one showing the max can be a lot, but it's all up to your end purpose. So to wrap this up, we'll go into some about alerting. So as I mentioned, Grafana has alerting, and so does Prometheus. They both are pretty intuitive. Prometheus's alert manager has been around from the beginning, so it's a little bit more mature. It can support any PromQL query and also has complex routing support for going to Slack, PagerDuty, email, whatever, and also offers silences and inhibitions. So if there's, you plan downtime, you can just silence your alerts so that way they're not going to go off saying the server's going down because you know it's going down. Inhibitions are useful for if you have warnings and then you have critical alerts. If you already have the critical going off, it doesn't make a whole lot of sense to now get a warning and alert to you. So that's where you can inhibit warning alerts. Grafana also supports being a Prometheus scrape target, which is interesting and helpful. And Grafana also allows rendering what they call annotations. So it's shown here in this blue line. And you can make annotations based on Prometheus queries. And this Prometheus query will query alerts that Prometheus has sent out. In particular, this one is going to find, if you give it a specific name, wherever that alert has gone to pending or firing. And so then you would see a dashed line for every time that alert has gone off. So I also include some different links there if you're interested in that. So to make effective alerts, the important thing to know is how can you aid the person who needs to take action in taking action? They need to be actionable in that person's context. And so most of my advice really reinforces kind of that whole thing about being effective and doing whatever your purpose is. And in this sense, a lot of typical user experience things apply here. Think of what the person getting the notification is going to do. And if it's an alert that something's wrong with a server, for example, they're probably next going to want to know which server or what's wrong with it. And so watch over time if people respond to the alerts by doing the same thing every time. If the same action is always taken, then refactor that into the alert itself. If the first thing they do is go to a wiki page, embed a link to that wiki page in the alert. If they go to Kibana and look at searches, embed that search link into the alert. So then they can just click it, and they're gone to a pre-done search that just shows the error. There's really no reason not to. Prometheus is extremely powerful and gives us some capabilities. So it uses Go templating to power everything. And so if you were going to make your wiki alert, that's all that you would need to do in the alert there, and it will replace that group label's alert name with your alert's name. And I, again, also provided some links so that we'll go into way more detail about that. So probably the best thing about these two projects is that they're both open source. I just want to implore you to think outside the box. There's lots of ways to contribute. Individuals can do it. Companies can do it. You can do it from just reporting bugs to actually fixing things. But then there's also things, all of these technologies, Grafana and Prometheus, have basically ecosystems around them. So Grafana has different data sources. You could maybe make a new data source for them, make a new chart. They even have an ecosystem for sharing dashboards. So if you're running Kafka and you've made a great Kafka dashboard and it's not specific to your company's secrets, why not share it and maybe help somebody else with their Kafka? You could, for Prometheus, also make a new exporter, or you can make a new client library. Maybe there's a different language like DLang or something that doesn't have an exporter that could use it. So that's pretty much it. Thanks for coming. That's my talk. I hope you found it useful and enjoyable.